Welcome to another video on control systems. So in this video we'll see the frequency response of systems using Nyquist plots. So we will find the stability of the system and also determine the gain and phase margin of the system. Before we start, okay, these are the prerequisites for this particular video. Okay, with these things, let us. This is a first open loop transfer function. We are asked to find what is the stability of the system. After finding stability of the system, we are asked to find what is phase margin and gain margin of the system. So let us start with locating the poles and zeros of this system in S-plane. So this is in S-plane where the poles and zeros are there. So let us locate the poles and zeros. Now there is a pole at origin. So there is a pole at -2. There is a pole at -3. Let us write the Nyquist contour. This is the Nyquist contour. So as we know, this is up to infinite. This is also up to infinite. This is actually explained. So we write this as the direction of the contours. This is segment 1, segment 2, segment 3, and segment 4. There are 4 segments. So while mapping each of the segment onto GH plane, so we substitute in the first segment. So S is replaced by j omega, where omega is ranging from 0 to infinity. In the second segment, we replace S by r e power j theta, where r is tending to infinity, theta is ranging from 90 degree, 0 degree, and minus 90 degree. Meaning this is from 0 to infinity. This is in positive imaginary axis, and from this to this entire segment is r e power j theta, where the magnitude is infinite tending to infinity, and this angle is plus 90 degree. This is 0 degree and minus 90 degree. The third segment is exactly the mirror image of first segment, so we're not too much worried about it, because it will be S is equal to minus j omega, and omega ranges from 0 for infinity to 0. So that's how the omega is changing from. And how about the fourth segment? Fourth segment is nothing but S is replaced by rho e power j phi, where rho is tending to 0, phi is ranging from, this is from minus 90 degree to 0 degree to plus 90 degree. These are the values of S in different segments. So let us start the mapping of each and every segment. So to map the first segment, so in GH plane, so let me write this as my GH plane. In my GH plane, so we have GFS into HFS is given by 100 by so and so. Let me replace S by j omega. Now this will become j omega into j omega plus 2 and j omega plus 3. So you have this as your first segment mapping. And to write the magnitude of this, it is 100 divided by omega under root of omega square plus 2 square under root of omega square plus 3 square. So this is the magnitude of this. The phase angle of this is minus 90 degree minus of tan inverse of omega by 2 minus of tan inverse of omega by 3. So this is what is the phase equation is. So let us try to write what is for different values of omega, what is magnitude and the phase. So let me write this as the phase angle. So this is phase angle. So you know that it is ranging from 0 to infinity as from our first segment variation. So when it is 0, we know that when this is 0, the magnitude will become infinite. When it is 0, it is minus 90 degree. When omega is infinity, this will become infinite, and anything by infinity is 0. And when omega is infinity, this is already minus 90, this is minus 90, minus 90, this is minus 270 degrees. Now we know that this all these angles are minus, so we'll certainly end up with a minus 180 degree phase. And let us find out the omega for which this phase is minus 180 degree, which we call it as omega PC. So let me find out that it is minus of 180 alpha equals minus 90 minus tan inverse of alpha, sorry, minus tan inverse of alpha a by 2 close minus tan inverse of alpha a by 3 close, shift cal. So now omega PC comes out to be, so it is 2.449 radian per second. This is omega PC, and let us find what is the magnitude at that point. So what I'll do is now 100 divided by, open the parenthesis alpha a multiplied by, open the parenthesis, under root of, again open, alpha a square plus 2 square, close the parenthesis into, open, square root, open, alpha a square plus 3 square, close, close. Calculate for 2.449. The magnitude is 3.33. The magnitude is 3.33. So at omega PC, magnitude is 3.33. So what I'll do now, I will equate this magnitude to 1, and let me find out what is omega. So what I'll do now, I will simply equate this to, I will make it alpha equals shift cal, and get omega GC. So it is 4.185. So at this 4.185, let me find out, it is okay, minus 90 minus tan inverse of okay, 0.5 alpha a minus of tan inverse of alpha a divided by 3, calculate, okay, calculate for 4.185. The phase is minus 208.3 degrees. So now I have all these points which are critical. Now let me draw the plot now. Which is this point corresponds to, okay, which is infinite at an angle minus 90 degree. So we know that this is 0 degree, this is plus 90 degree, this is plus 180 degree, this is plus 270 degree. Anti-clockwise rotation is positive angle, clockwise rotation is negative angle. So this is 0 degree, this is minus 90 degree, minus 180 degree, minus 270 degree, correct? So now if you, of course, let us take the magnitude as infinity here. You can see infinity triangle minus 90 degree corresponds to this. We can see the magnitude is keep reducing and phase is keep increasing from minus 90 to minus 270. So it actually goes like this. So this is how it is going. Okay, this is the first segment, and let us write the second segment mapping. Let us keep this here. Uh, when the phase is minus 180 degree, the magnitude is 3.33. That is, the magnitude at this point is 3.33 at an angle minus 180 degree. Minus 180 degree. Okay. Fine. Let me write the second segment mapping. If you start doing the second segment mapping, if I just do it here. Okay, let me just do it here only. For the second segment, what we have is, for the second segment, S is replaced by R e power j theta. This will now become 100. Let me just write it in a different pen. It is 100 divided by R e power j theta. So you just simply substituting for wherever this is there. So this is my transfer function. This is my transfer function for which I'll be writing. So this is a transfer function R e power j theta. Then now it is R e power j theta plus 2. Then it is R e power j theta plus 3. So wherever s is there, I'm replacing it by so. So when r is tending to infinity, this will become 0, this will become 0. And then what you have? So you have 100 divided by r cube e power j 3 theta. So this is the value. So then when r tends to infinity, because r we know that if you want to tend to infinity, then this will become 0 at an angle minus 3 theta. But theta ranges from plus 90 degree, 0, minus 90 degree. So then this entire second segment mapping will reduce to 0 at an angle minus 270 degree, 0 degree plus 270 degree. Yep. We know that the first segment is ending at minus 270 degree 0. This is your last point of your first segment. You can see the first point of your second segment is same. That is, handing of baton from this to this will happen at this point. So you have it's a dot at the origin. Then how about the third segment? As we already know that third segment is a mirror image of the. This is a mirror image of the first segment. So now you can simply write this as a mirror of it. So if you put the mirror, it becomes like this. So this is your mirror image. This is the direction. We know that this is 3.33, and this minus 1 plus j0 will actually come inside that. Okay, this is my third segment. How about the fourth segment? For the fourth segment, let us write what is g of s into h of s, where s is replaced by rho e power j phi. So it is now 100 divided by rho e power j phi and rho e power j phi plus 2, rho e power j phi plus 3. If you substitute these things and then apply the limit of rho tending to 0, this is 0, this is 0, this you can neglect. Now what will happen to this? This will become 100 divided by 6 rho e power j. So when rho is tending to 0, this will tend to 0. So this will become infinity at an angle minus 5. Correct? It is infinity at angle minus 5. So but what is phi is ranging from? Phi is ranging from minus 90 degree, 0, plus 90 degree. So this will become infinity at an angle. So this will become minus of minus is plus 90 degree, 0 degree and minus 10 degree. Correct? So now where this has stopped, see here, this is your fourth segment. Fourth segment should start from this point. Here, this is the end of your third segment. So what is the starting point of your, see, the end of your third segment is infinite at an angle plus 90. So is it the starting point of your fourth segment? So now the baton handing over will happen at infinite at an angle plus 90 degree, which is plus 90, 0, minus 90. So now the contour will be like this, the contour in GH plane. So this is what is fourth segment with magnitude as infinity. With magnitude as infinity. This is how it is going. So now this is minus 1 plus j0. So let us find out what is the stability of system. So hope you got this one. So this is our fourth segment mapping. Fourth segment mapping. The fourth segment mapping is infinity at an angle plus 90 degree, infinity at an angle 0 degree, infinity at an angle minus 90 degree. So this is how it goes. Now we need to find what is the stability of the system. Stability of the system. Stability of the system is to know the value of z. What is this z? Z is nothing but number of zeros of 1 plus gfs of into hfs, or 1 plus zeros of f of s enclosed by the Nyquist contour. We are actually looking into how many closed loop poles are there to the right hand side of the plane, which is, now we know that it is n plus p. What is p here? Because p you have to get it from this. So how many number of poles are there to the right hand side of the plane? So p is actually 0 here. So p is 0. So p is actually 0. But what is n? N is nothing but number of encirclement of this minus 1 plus j0 line by the contour in GH plane. So how to find how many times this minus 1 plus j0 is enclosed, encircled? Just draw a line anywhere outside, anywhere just going out. See how many times this contour is cutting this line. Can you see this is cutting once in clockwise, two times in clockwise? So n is equal to 2. N is equal to 2. So now n is 2. So z is actually, what does this z2 means? Z2 means two closed loop poles are there towards the right hand side of the H plane. Towards the right hand side of the H plane. Now, since there are two closed loop poles onto the right hand side of the H plane, system is unstable. System is unstable. Okay, now when the system is unstable, what is the margin? How far away it is from the imaginary axis? For that, you need to find what is gain margin. Gain margin is nothing but 1 over the magnitude at omega equal to omega c. This is the magnitude. So how much is this magnitude at omega that we got it here? So this is omega pc. Magnitude is exactly 1 over 3.33. This is your gain margin. So what is this gain margin? So it is 3.33. 1 over is 0.300. So this is my gain margin. How much is phase margin? Phase margin is nothing but 180 degree plus the phase at omega gc. So this is nothing but 180 degree plus, can you see how much is the phase at omega gc? Right, phase, it is actually minus 208.3 degrees. So now the phase margin is minus 28.3. So gain margin is 0.3, phase margin is minus 28.3. So what is this 0.3 in terms of dB corresponds to? You can say it as log of answer, 20 log of 0.3. You see how it is minus 10.45 dBs. This is the gain margin in dB. This is phase margin in degrees. This is phase margin in degrees. So what is the significance of this gain margin of 0.3 is, now the existing gain is, existing existing root locus gain is 100. If you multiply this by 0.3, which is the gain margin, the system will become oscillatory. if the existing gain, if it is multiplied by gain margin, whatever the system condition, now anyhow the system is unstable. If you multiply the if you multiply the gain by the gain margin, then system starts oscillating. That is, when the gain of the system, sorry, when this 100 becomes 30, then system is oscillating. It will not be unstable, it will be oscillating. It will be oscillating. That's what is the significance of this gain margin. Let us move on to uh, one more question. So let us take up the second in the series. Let us take this as GFS into HFS is equal to 40S divided by S minus 1 into S plus 2. S plus 2. So let me write the contour. This is the poles are at, there is a 0 here, there is a pole at minus 2, there is one more pole at plus 1. So this is our Nyquist contour. This is Nyquist contour. So now P is actually equal to 1 because one pole is towards the right hand side of the plane. So now we need to find the value of 1 so that we know what is the value of that. So let us start mapping. So let me not repeat this step again and again. So this is common for all the problems. So you are replacing, of course, here also you have 4 segments. First, second, third, and fourth segment. So I'll be just substituting these as the values of S for the first segment, second. So for the first segment mapping onto GH plane, it is now 40 g omega divided by g omega minus 1 g omega plus 2. Correct? Now this will become 40 omega divided by under root of omega square plus 1 under root of omega square plus 2 square. That is the magnitude. The phase angle is plus 90 degree, and see here this is since minus 1 is there, so I have to do minus of 180 degree minus tan inverse of omega and minus tan inverse of omega by 2. That's my phase. How about the variations? Okay, this you can further write it as minus 90 degree minus tan inverse of so it will become plus tan inverse of omega minus tan inverse of omega by 2. Correct? This is minus, this is plus also. Now let me find out for omega magnitude and phase angle. This is 0, infinity. When it is 0, you can see this will become 0. The phase will become, okay, this is 0, this is minus 90 degree. When omega is infinity, so when this is infinity, here also magnitude is 0. What will happen to phase? This will again minus 90 degree. Correct? Because this will become plus 90, that will become minus 90. These two will cancel out, will end up in. So this is your at omega 0, you'll get 0 magnitude minus 90 degree as a phase. At infinity also magnitude is 0 and phase angle is minus 90 degree. But it is interesting. Let us see how the plot goes. What you can do is you just give it as point 1. Give it as point 1. Let us see how it goes. What happens to the space. You can see here this is actually this is plus tan inverse of omega. This is minus. Since now this is dominating, plus dominates. Now this will be minus 80 something. You'll get it. So what I'll do, minus 90 plus tan inverse of alpha a minus tan inverse of zero point 0.5 alpha a. Calculate for zero point 0.1. Can you see now it has become minus 87.1, and for maybe for zero point 0.5, calculate for zero point 0.5, it is minus 77 degree. Calculate for 1 or 10, it is for 10 it is minus 84.4 degree. Can you see the angle slightly reduces and then again goes towards minus 90. Of course, I'm not okay. You can actually find out what is the magnitude also. So now, if you look at the magnitude, it is 40. It is now 40 into alpha a divided by under root of okay, open parenthesis square root open alpha a square plus 1 close into open square root of square root of alpha a square plus 3 square close. Calculate for zero point 0.1. It is 1.32. Calculate for 0.5. It is 5.88. Calculate for 10. It is 3.81. Can you see this keep reducing? Okay, this actually goes slightly increases and then comes down to 0. Okay, if you try to do this, what is this? So this is how it looks like. Okay, this is the GH plane. In GH plane, minus 90 degree. This is actually minus 90 degree, and minus 87. They all come here. So what might can happen? Can you see this? This actually goes like this. So this is 0 and minus 90 degree. Minus 87 comes somewhere here, and then it again. So minus 77 comes somewhere here. Is it somehow happening like this? Sorry, it actually goes like this again. This actually goes like, because this again minus 90 degree. So this is not that way. Let me just rewrite this. This is going like this, minus 90, and then again it goes to this goes somewhere here, and then again it just goes to this. This is how your first segment. Second segment, if you see what happened to second segment, give me the second segment mapping. It is okay now 40 r e power j theta divided by r e power j theta minus 1 r e power j theta plus 3. This will go off, this will go off, and this is, because now r is infinity, means it is 0 at an angle. This is infinite f2 phi, there it is. It's actually minus phi, correct? So then phi is ranging from minus 90, 0, plus 90. Sorry, plus this is theta. Plus 90, 0, minus 90. So then this will become minus 90 degree, 0, plus 90 degree. So you stop here and you have to start from the same point. So it's a dot at the origin. So it's a dot here. It's a dot here. How about the third segment? Third segment is exactly the mirror image of this. So it actually becomes this. Correct? This is how what is happening here. This is the second segment. Wait, third segment. This first, second is dot. Third one is this. How about the fourth segment? Fourth segment, I have to map it with s is equal to rho e power j phi. So it is now 40 at an angle. So rho e power j phi divided by rho e power j phi minus 1, which is rho e power j phi plus 2. When rho is 10 to 0, this becomes 0, this becomes 0. You end up with minus 40 rho e power j phi, and this is minus 2. So this minus will actually become this you can write it as 2 at an angle minus 180 degree. So when that goes there up, it will become plus 180 degree. So this is rho tending to 0. So when rho is tending to 0, this will become 0 at an angle minus this will become plus 180 degree plus 5. Correct? When it goes up, it will become plus 180 degree plus 5. So phi is ranging from minus 90 degree 0 plus 90 degree. So then this will become 180 degree minus of 90, 180 degree 0, 180 degree plus 0, 180 degree minus 90 degree. Correct? Sorry, this is plus. So can you see now this is 0 at an angle. So what is this? This is 90 degree and 180 degree and 270 degree. If you see all these things, can you see the magnitude is 0? You are actually here. So you are there at plus 90 degree. So you actually came there to plus 90 at an angle. So plus 90 degree and the magnitude is 0. So what is this now? This is a magnitude 0 and this is magnitude 0, phase angle is this. So you have the fourth segment is also a dot there. Fourth segment is also a dot there. So this is your uh, this is a Nyquist plot. So where is 1? This is minus 1 plus j0. Is this minus 1 plus j0 is encircled by this Nyquist contour in GH plane? No, this is not at all encircled by. So n is equal to 0. What was p? P was actually equal to 1. P was actually equal to 1. So then what is that? It is n plus p. It is 0 plus 1. It is equal to 1. So system is unstable. But the system is unstable. What is gain margin? So system is unstable. So because z is equal to 1, what do you mean by z equal to 1? Z equal to 1 now means there is one closed loop pole lying to the right hand side of this plane. So that's what is very clearly seen here. So this is open loop pole, which happens to be the closed loop pole also when you close the loop. So this z equal to 1 means that system is unstable. So gain margin, since it is not at all encircling, gain margin is actually equal to gain margin is 1 over, because this can never become uh, stable. So it's actually minus infinity. It is like 1 over 0 because this will never encircle. still ever this n can never become minus 1. When n can never become minus 1, the gain margin is actually minus infinity. Minus infinity. How about the phase margin? Phase margin is also not valid because phase margin is also not valid because why phase margin is not valid? Phase margin is not applicable because the magnitude is never becoming 1. Magnitude is never becoming. Okay, what you can do is, because you can certainly find out what is, okay, let us find out what is phase margin. Phase margin is where the magnitude is 1. Oh, can I find out what is the magnitude when this becomes 1? Okay, there is a certain amount of phase margin. Let us find out. So for what value of this one, this becomes to 1. So I can find out. So at 1.32 it is so and so. So let me just take the, okay, I have this, yeah, I have this magnitude. So let me make this alpha equals shift cal shift cal. I'm equating this to so and so. This is my omega. This is omega GC, which is nothing but 0.075. So omega GC is 0.075 radian per second. So what is the phase at omega GC? Okay, I can take out this phase equation. Where is the phase equation? This is my phase equation, which is minus 90 plus of tan inverse of alpha A minus of tan inverse of zero point 0.5 alpha A. Calculate for this. See, now it is minus 87.85 degree. This is what is phase margin. So phase margin is uh, phase at phase at omega GC is minus 87.85 degree. This is omega GC. So now what is the phase margin you have? Phase margin is nothing but 180 degree plus phase at omega GC. So it's actually 180 degree plus 180 degree plus what? 180 degree plus this is minus of 87.81 degree. So now this comes out to be plus of 180. It is 92.14. This is phase margin. Now you can see phase margin is positive 92.14 degree. Gain margin is minus infinite dB. So what is the stability of the system? Stability of the system comes into picture. Now in this case, Z, what do you mean by phase margin of plus 92.14 degrees? Now Z is equal to 1. This is gain margin. This is phase margin. So when Z is equal to 1 and gain margin is negative, phase margin positive means when Z is equal to 1, system is unstable. That is for sure. That's for sure. What is this gain margin of minus infinity dB means? You reduce your gain by whatever value or increase it by whatever value, the system will never oscillate. The system will never oscillate. So that's what is gain margin means. Now, what is this phase margin of 92.14 degree means? If the pole position, zero positions are altered in such a way that if the phase of X changes by 92.14 degrees, if it deteriorates, then system starts oscillating. System starts oscillating. The system is unstable now. The system is unstable. Can the system become oscillate? Yes. When does the system can become oscillate? It is not by changing. It is not by changing this gain. This is okay. Root locus gain. But by changing the poles and zero position, you can still make the system to oscillate. That's what is this phase margin positive means. Again, let me repeat. Since Z is 1, what do you mean by Z equal to 1? It is number of closed loop poles onto the right hand side. Since it is one, system is unstable. Now you have to decide that system is unstable. Now what is the gain margin, phase margin? Gain margin, phase margins will indicate when does the system will oscillate. When does the system will oscillate? Gain margin minus infinite dB means that you reduce the gain by whatever amount, it will never oscillate. What is this phase margin of plus 98 point something will do? This says that if you increase, if you deteriorate your phase margin by 92.18 degrees, then system will start oscillating. System will start oscillating. From unstable to oscillate, it is possible. So that's what the meaning of this gain margin minus infinite dB and phase margin positive. Of course, uh, gain margin, phase margin will not exclusively say whether the system is stable or unstable. When Z is 1, this is certainly says that this is unstable. And the system becomes stable. So system can never become stable, because you can see, if you can see this root locus. So suppose if I write the root locus of this is how it goes. This is how it is keep going. So system is always having poles towards the right hand side for all values of k less than infinity. For all values of k less than infinity. So system is absolutely unstable. So that's why you have it as minus infinite d. Okay, this is an interesting thing. Okay, we shall see another problem. So we will see this. So it is third one, 40 into x plus 2 divided by x square into x plus 6. So if I just write it in explain, is how it goes. This is so your first segment, second segment, third segment, this is the fourth segment. Let me again not repeat the segment positions. So sorry, the s values of the segment. So this again continues for this. If I try to write the first segment mapping, so the magnitude will become 40 into under root of omega square plus 2 square divided by omega square under root of omega square plus 6 square, and the phase angle will become minus 180 degree plus inverse of omega by 2 minus inverse of omega by 6. Let's change the value of omega from 0 to infinity. Let us know the magnitude and phase angle. This is okay, infinity. Phase angle is minus 180 degree. This is 0. Phase angle is again minus 180 degree. Give it as 0.1. If you can give it as 0.1, you can see the phase angle actually slightly goes more uh, positive than minus 180. You can actually find out it is minus 180 plus of 10 inverse of 0.5 alpha a plus sorry, minus of 10 inverse of alpha a divided by 6 close. Calculate for 0.1. Can you see it is minus 778? It is minus 178. And if you are calculating further again somewhere here, so for calculate for 1, it is minus 162. Calculate for 10, it is minus 160. Calculate for 100, it is minus 177. This is how it is going. This is how it is going. That is segment 1. Okay, if I try to plot the corresponding, this is minus 180 degree with a magnitude of infinity. Can you see it is 0 degree, minus 90 degree, this is minus 180 degree, this is minus 270 degree. It's actually going in the second quadrant only. It actually goes like this, and then I think it's going like this. Correct? Magnitude is going from infinity to 0, and hopefully uh, the second segment would be a dot at the origin. So if you can see, is it not s is equal to r e power j theta? Maybe by this time you can directly write it is r e power j theta by r square e j theta and r e power j theta. This will become, this will go off. You see now it is 0 at an angle minus 2 phi, sorry 2 theta. It is 0 at an angle minus 180 degree, 0 plus 180 degree, meaning it's a dot at the origin. Second segment is dot at the origin. Third segment is equilateral with the mirror image. It actually goes like this. So this is how it is going here. This is the first segment. Sorry, second segment is a dot. The third segment is the mirror image. The fourth segment would be S is rho e power j phi. So then this becomes 40. This is 2, and this is rho square e power j phi, j2 phi, and this is 6. So this is actually infinite angle minus 2 phi. Phi is ranging from minus 90 degree, 0, and plus 90 degree. This will become infinite at an angle. So plus 180 degree. We can also split this to minus 45 degree. So then this will become plus 90 degree, and then it is 0. If it is plus 45, then this will become minus 90. Then this will become minus 180. Correct? So it is infinity at an angle of plus 180 degree, plus 90 degree, 0 degree, minus 90 degree, and minus 180 degree. So this is the first one, and then it goes to you're at this point, it goes to this, then it goes back here. So this is minus 1 plus j0. This is not at all encircled. So n is 0. How much is p? P is also 0. That is n plus p, which is 0 plus 0, it is 0. So what is gain margin? Gain margin is actually infinite degrees because the system is absolutely stable. The system is absolutely stable. Have a phase margin? Yes, you have a phase margin. How much is phase margin? So phase margin is that value where it is 180 degree plus the phase at omega gc. How much is omega gc? So how do I find omega gc? For finding omega gc, you have to equate this to this so that at some point the magnitude will become 1. Magnitude will become 1, for which what do I do? It is 40 into under root of alpha, sorry, alpha a square plus 2 square close divide by, okay, I have to equate. Okay, let me alpha equals into alpha a square into root of into alpha a square plus 6 square, close, shift cal. So this is at magnitude of when omega gc, it is at 5 point. So omega gc is 5.32 radian per second. At that point, what is phi at omega gc? Phi at omega gc is, so it's now minus 180 degree plus tan inverse of 0.5 alpha a minus tan inverse of alpha a divided by 6 close, calculate at 5.32, it's actually minus 152.17 degrees. So what is phase margin? Phase margin now is 180 degree plus minus 152.17 degree. So phase margin now is plus of 180 is 27.82 degrees. If you just go back, gain margin is infinite dB, whereas phase margin is 27.82 degrees. So system is stable. System is not simply stable, it is absolutely stable, meaning by changing the gain by whatever amount, the system will never become oscillating. System will never become oscillating and it will never become unstable. Right? So that's what is this. So in the previous case, you can see the system was absolutely unstable because you cannot make the system to make the closed loop pulse onto left hand side. Here it is unable to bring it to right hand side. So here system is absolutely stable in this particular problem. Okay, we'll do few more such problems in the coming video. Thank you.